Hi everybody, welcome to the last video in this series, and I'm telling you, I'm kind of glad to have this thing done and be able to get it off my bench. It's been a great project, but it has been very time consuming, and quite frankly, I have quite a few other things I'd like to do, so it'll be nice to get this finished. So I'm going to do, this last video is just going to be a final testing of the unit to make sure everything's working properly, and I thought I'd let you come along for the ride for a few of these things. I'm not going to show you every little thing, and it's also kind of testing out the new test equipment set up with the PA81 and so forth, and see how things go. Now the first thing I'm going to do is a little bit different than I've done in the past. We're going to test the phono stage. And the way we're going to do it is we're going to use the MDO2204 and the frequency analysis application in it in order to do a frequency analysis curve or a Bode plot of the RIAA equalization in the phono stage. So first of all, let's look at what it should look like. So I have done videos on RIAA equalization and on pre-emphasis and de-emphasis and all that. You can look up some of those things, or you can just look it up online. There's lots and lots of information about it. Now for those of you who aren't into vinyl and don't care about it, well, this probably isn't going to mean too much to you, but this is a classic piece of audio gear. One of the central points of audio at this time when this thing was being built was vinyl records. So we want it to work because whoever is going to purchase this is going to want to use it probably as it was used back in the day. So this is what the curve looks like. So whenever a record is encoded, you know, the recording is encoded onto the record itself, this is the curve that's put. So they attenuate the signal kind of like this. It's not a straight line. It's a little bit curved, and they use a minus 20 dB attenuation at 20 hertz, and they emphasize it 20 dB at 20 kilohertz. And right at the crisscross point there where there's no boost or cut of the signal is right there at 1 kilohertz. That's kind of your crossover point. So what I'm going to do is I'm going to run the frequency analysis. I'm feeding the signal directly into the phono stage, and I'm going to read it back out from the record jack. So instead of running it through the amp, because I don't want the amplifier or any of the circuitry or any of that to be in my way. I just want to see if the phono stage is doing its job. So when we're done, we should get a line that looks something like this. At 20 hertz, we should see it be about 20 dB higher than at 1 kilohertz. And at 20 kilohertz, we should see it about 20 dB lower. So let's set up the system and do the test. Okay, I started the test. You can see it automatically attenuates the signal to get the correct output and everything. Don't pay attention. We're not so worried about the phase shifting and everything. That really isn't what we're looking at. We're looking at the blue line, which is the gain. Okay, so we can probably mess around with the scale on this. Okay, just changing the offset of the scale just to make it match, give us some round numbers. You can see that at 28 and at 28 dB, that's where we're at 1K. So 20 hertz should be 20 dB higher than that, and 20 kilohertz should be 20 dB below that. So let's do a little bit of counting here. So if we start at 28 and I add 20 to that, that's 48. And there we are. And if I take 28 and I subtract 20, that should be about 8, and here's 8. There's 20K. We're just a little bit below that. So that's, you know, when we compare them, compare the red line on this to the blue line on this, and you will see that they're pretty darn close. So I think we're good. So that's a useful test, and I will be able to use that again if I'm ever testing a phono stage. So I really like this thing. This has been a good piece of test equipment up here. Okay, the next thing we're going to do here is our power and distortion test. And let me make a couple changes here to my setup. Okay, I'm going to do 3 tests. The first one we're going to do is at 1 kilohertz, and the scope is just to kind of view the waveform a little bit. I hope you can see it on the camera. The THD is self-explanatory, and then we have the PA81 set to read out watts, or as they like to say, watts RMS, or RMS watts. So right now the Keithley is connected directly to the input of the PA81. You can see right here, and it's sharing the speaker leads with the PA81. All right, so let's see what kind of power we get out of this amp. All right, here we go. So right now we're on ×1, so that's 1 watt per channel. You can see the scope up here. And THD is very good. There's about 24 watts. Now it's going to change scales, and it does. So now we're on the ×10 scale, so this would be 50 watts. So let's keep going up. There's 150 watts per channel, and I am driving both channels, as you can see. And there's 200 watts, and it still isn't breaking up yet. And right there at about 240 watts is where it starts to distort a little bit. I'm not going to drive this too hard. Okay, so that shows what we have there. Okay, we're now going to try 20 kilohertz. We should be able to get similar power. And this can't really read at 20 kilohertz, by the way. It's the way it's set right now. But you can see it's not, the waveforms are staying really nice. There it goes, it just tripped. So we got a little bit of clipping there. And that was, over 200 watts. So I think we can tell that the 20 kilohertz is good. So now let's go to 20 hertz. Okay, moving to 20 watts, or 20 hertz. This is going to be an issue because you're right, that's the absolute bottom frequency that this thing can read at. It cannot go to 19 hertz. So it's not going to be accurate. It'll be close, but not, it's not going to read perfectly. So let's turn this up. And at low signal, you can see, hold on, and it even takes it a second to settle here. Hold on, because I have some filtration on there, which also affects it a little bit. And there's about 75 watts per channel. You can see it's still doing a pretty respectable job. There's a little over 100 watts per channel. And you can see it reads a lot higher than 1 kilohertz, but part of that is the meter. Part of it is also the cabling. So we're directly connected right now into the PA81. So now what we're going to try is something different. I have this wire, and it's connected directly to the speaker terminals. So I'm going to disconnect these. So now we're directly connected to the speaker output terminals. And I don't think this is going to make a huge difference. I'll explain why later, but it may make a little bit of a difference. Okay, in between phone calls here. So 20 hertz now directly connected to the speaker terminals on the back of the amp. And if I go up, and it's going to have to settle Okay, there's about 120, 130 watts per channel, and it's about the same. So really that doesn't make any difference. Sometimes there could be a little bit of signal loss across the speaker wires, but these wires are so short, they're maybe only 1.5 meters long, if that, or, you know, I don't know, 4 or 5 feet, 6 feet. So no big deal there. So long story short, that is probably not the actual distortion figure, but this thing never has been very good at measuring 20 hertz. And bumping up the frequency just a little bit on the signal generator, you can see what happens. It falls right in line. Again, it's limitation of your test equipment. So I have to admit, I do like this setup. That makes it easy. Other than I have this scope running off of batteries right now, and it, you know, it times out after a couple minutes and turns itself off. So you have to just keep turning it back on. I could plug it in, but I kind of like it being isolated from everything like that. Now, another thing I wanted to mention, the last 2 videos I forgot to bring this up, but I told you that the actual resistors on that one board were getting kind of warm. I showed you those 2 510 ohm resistors on the power board. And so what I did was I just removed them and I flipped them over to the other side, to the back end of the board, and attached them there. And now everything inside there runs really cool. Now you can feel right here, right under where those resistors are, you feel a little bit of a warm spot. Not hot, but you can feel that it's warmer here than it is right here. So those resistors do get hot, and that's the way this thing works. If we go back and look at the original amplifier board, you can see the problem here. This is the color that these capacitors should be. This is the color that they turn from being next to these resistors like that. So you can see that one. You can see how this one has discolored pretty badly. And it's from being around these resistors. This one has totally darkened and turned gray. And again, there's the same resistor on the other side that hasn't been exposed to that heat. So it's pretty interesting how these work. And you can see how the solder joints have kind of cracked and loosened a little bit, and the flux has kind of softened up and crystallized. These are all original boards. They've not been serviced. You can see how the board is like heated, and that's why I had a couple of questions as to why I just didn't rebuild these, and this is going to change the sound stage and the sound signature of the amp and all this, but absolutely 100% totally false. All these do is provide voltage. They do nothing else. They have nothing to do with the sound. Now, I could argue that if there is hum in the power supply, if it's not a clean DC power supply, that could induce hum. But I can promise you, this one didn't do that when it was new, and neither did the new board have. It would perform as good or better. The main purpose of replacing this board has nothing to do with sound and everything to do with reliability. If we were replacing the amplifier boards, if we were replacing the Phono stage or the preamp boards, then yes, I would make an argument that yes, it could affect how the amplifier performs. If you are a purist and you want it to sound the same. But there will be absolutely zero change. I'm going to repeat myself on this, by replacing a power supply board like this. And you will not have this kind of stuff going on. And that was really my main goal in replacing those boards. And the same thing goes for the relays. The modern relays are better quality. They're very plentiful. They're very inexpensive. They're easy to replace. They're easy to find. So again, it gives this receiver longevity. And hopefully this thing will be sitting on somebody's audio shelf playing music 30, 40 years from now after I'm gone. So that's what I'm hoping for. So I can play around. We can check slew rate, and we can check intermodulation, distortion, all these other crazy things. It's not necessary. We know how these things perform when they're, up to spec. The 3-point test, 20 hertz, 1 kilohertz, and 20 kilohertz. Looking at max power, looking at the distortion, all those things. I think that's mainly what we needed to check. And believe me, I've tested this thing every other way you could. It's just, I need to get this off the bench, and I'm not going to spend a whole lot more time on the video here. So again, everything turned out great. I tell you, this would be something that I would keep personally, but I think speaking with Dave, we're going to sell this one. It's going to go up for sale. If there's a lot of interest among any of you, I may perhaps put a link in the in the description of this video. And if you don't see that link, or you read the link and it says it's sold, that means it is sold. So I have so many people that I make a mention of something, and they'll look at a video 3 years later and they'll ask a question like it was just posted yesterday. So just understand, this thing's probably not going to be around for long. If we decide to sell it, it's going to sell pretty quick. If I put a note in there and it's recent, and you want to, email or whatever, feel free, and we can talk about it. I have to talk with Dave what we're going to do. I have a lot of money and time in this one, so I don't think this is going to be a cheap one. We're always try to be fair with our pricing, but you got to at least get out of it what you put in it so you don't lose money. But anyway, until next time, I wish you all peace, joy, happiness, and good health in your lives. And we'll see you again real soon. And like I said, so many things I need to get on this bench here. And of course, it wouldn't be a final video if we didn't play Stranger Danger. So let's just play a little bit, a couple seconds of that. And there we go. So take care, everybody. Bye-bye.